This is lipopolysaccharide or endotoxin. It is an important and high-risk research tool, which is why I'm wearing a glove. And it can help us understand conditions like myalgic encephalomyelitis, chronic fatigue syndrome, or ME/CFS, fibromyalgia, long COVID, and Gulf War illness. Now keep this in mind, and I will talk about this again toward the end of the video. So, one question you might hear about ME/CFS from someone who doesn't have the condition is something like, I get fatigued all the time as well, but I still have to get everything done. Why can't these people with ME/CFS just power through it? And when you hear a question like that, you may not know what the accurate answer is. And so I want to explain the scientific biomedical answer to that kind of question. Why can't you just power through the fatigue? I think the initial response from many people with ME/CFS is something like, this isn't the same fatigue as what you're talking about. This is not normal fatigue. It's something different. Fatigue isn't even the right word for it. And that is true, but what does that really mean? So for a large percentage of ME/CFS sufferers, I think the best analogy is to think of the worst flu or SARS-CoV-2 infection you ever had. Let's say your temperature was over 102 Fahrenheit, like 39 Celsius, and you couldn't even get out of bed for 2 or 3 days. So the idea of getting up and going to work or exercising was just beyond comprehension. You couldn't even imagine doing that in that state. So when you were that sick, why could you barely move? It's not like your muscles disappeared. So what was keeping you from doing things? What was keeping you in bed? And if you follow the channel, you know the general answer to this. The main reason is there are microglia in our brain, and when they detect a virus or a bacterial infection, they go into an activated inflammatory mode, and they produce pro-inflammatory cytokines in the brain. And these cytokines affect a lot of neurotransmitters in the brain. I can't go over all of them, so I'm just going to mention serotonin just as an example. So when the microglia, when you're sick, releases these cytokines, they deplete your tryptophan, which prevents you from synthesizing serotonin. And these cytokines also remove serotonin from your synapses, the space between your neurons, and so the serotonin can't dock with the receptors. Basically, your serotonin system is significantly suppressed. Now, the problem with that is that you have to have serotonin to do anything. You can't even lift your arm without sufficient serotonin in your brain. But beyond that, serotonin is also required for engaging what we call goal-directed behavior. So for example, imagine you're so sick you can barely move and you're really thirsty, but the drink is on the other side of the room. How do you get the drink if no one else is around? Well, first you have to identify getting the drink as a goal. Then you have to make this reward cost analysis to decide that the goal is worth pursuing. Then you have to formulate a plan to reach the goal, and then you have to implement that plan by starting to move. Now, all those things happen automatically in normal circumstances when we're healthy, but these are actually very complex steps that require a lot of parts of our brain to do successfully, and all of those steps require serotonin. And they also require dopamine, but I'll talk about that another time. I'm just mentioning serotonin for now. So that goal-directed behavior, just to do a simple thing like getting a drink, requires serotonin. So if your serotonin is wiped out by microglia activation, you can't do any of those things. Not only can you not move, but your ability to even develop goals and pursue them are suppressed. Basically, if your microglia are really, really severely activated, all you can do is lie down and sleep. So through this chain of events, microglia activation suppresses your ability to do things and suppresses your ability to consider doing things. Now, when you're sick for a few days, and that's the reason why your microglia are in their inflammatory state, that's fine. That's what the system is designed for. It's a very important survival tool. You want to stay in bed so you can fight off the infection. But if the microglia are chronically activated, such as what we see in ME/CFS and fibromyalgia and other conditions, your ability to function is chronically suppressed. The important thing is that when the microglia are severely activated, your inability to function, to do what you may want to do, it has nothing to do with motivation or willpower. And even if it did, your motivation and your willpower are dictated by serotonin and dopamine functioning anyway. So we're back to the same place. And so when we do the brain imaging and we see this microglia activated throughout the brain in ME/CFS and other conditions, we can see why the functioning is suppressed in those individuals. Okay, so why do I have a vial of endotoxin? Well, the reason we know these things I've been talking about is because we have research tools that allow us to explore the effects of infection and inflammation and microglia activation on behavior. And by injecting someone with endotoxin, we trick the body and the brain into acting exactly like they would if you were sick, but for a short period of time, just like 4 to 6 hours. And there's no real infection. You can't get sick in a real sense from this, although you can feel really, really sick for that 4 to 6 hours. You're not actually infected by something. So we can recreate the symptoms of ME/CFS in a healthy individual by injecting them with this endotoxin. So if we inject a healthy person with, say, 2 nanograms per kilogram, they will not feel very well at all. Their mood will be depressed. They'll have a harder time doing tasks. But I think most people who are healthy could probably still get up and move around and do basic tasks and probably even some cognitive tasks. But if we went to a higher concentration and injected someone with 8 nanograms per kilogram, they wouldn't be able to do anything. They would be stuck in the hospital bed in the study room, unable to function until it wore off. And we could take them to the scanner and we could see all their microglia activated if we wanted to. By the way, I don't give doses that high. I think it's too risky. So I give much, much lower doses in the studies I do. So the point is, if someone says, I don't understand why people with ME/CFS can't just power through it, I could say, well, let me inject you with this, and then you'll understand. I wouldn't actually do that, but it's a possibility. So the bottom line is, if you have chronic activated microglia and brain inflammation, which at least 35% of ME/CFS sufferers have, it is expected that you will have substantial reduction in your ability to initiate and maintain physical and cognitive effort. There's really no mystery there. We've known about those physiological systems for decades. The trick is figuring out where in that complex chain of events we need to intervene, and how do we correct the abnormalities in an effective and safe way, in a way that doesn't cause other problems. And that's what I'm trying to figure out. I will be talking about this a lot more in future videos, so I hope you can stay tuned, and I will be back soon.